transformations. First off, we need to talk about all the possible transformations that can happen to a function. Our parent function is f of x equals x squared. Now, let's make a list of things we'll be adding to our original function, and we'll see what different transformations happen to it by looking at the graphs. As we can see, the blue line has moved 2 units up when in comparison to the parent function, which is in red. This means that the plus 2 moved the parent function x squared 2 units up. Our next function is x squared minus 3. Pay close attention to how subtracting a number rather than adding it changes the direction of the transformation. This time, the blue line moved 3 units down instead of up due to the subtraction of the 3. This means that the subtraction of 3 moved the parent function x squared 3 units down. Our next function is x plus 4 squared. Instead of adding to x squared, we first add to the x, then square it. This time, the blue line is moved 4 units to the left due to adding 4 to x by itself rather than to the parent function x squared. This means that the addition of 4 to x moved the parent function x squared 4 units to the left. Our next function is x minus 11 squared. Instead of subtracting from x squared, we first subtract from the x, then square it. This time, the blue line is moved 11 units to the right, due to subtracting 11 from x by itself rather than the parent function x squared. This means that the subtraction of 11 from x moved the parent function 11 units to the right. Our next function is 2x squared. Now we're going to multiply x squared by 2. This time the blue line is vertically stretched by a factor of 2. This means that the multiplication of x squared times 2 made the parent function stretch vertically by a factor of 2. Next function is 1/2 x squared. So now we're going to multiply x squared by 1/2. This time, the blue line is compressed vertically by a factor of 1/2. This means that the multiplication of x squared times 1/2 made the parent function compress vertically by a factor of 1/2. Our next function is negative x squared. we're changing the parent function to a negative. As you can see by the graph, the blue line is reflected over the x-axis. Therefore, the transformation is a reflection of the parent function over the x-axis. Our next function is negative x squared. This time, the negative is in the parentheses. When we enter this function into the calculator, it ends up the same graph as negative x squared with the negative outside the parentheses. This is due to the fact that if we distribute the negative sign, we end up with negative x squared with the negative inside the parentheses. When we first add a negative to the variable of a parent function, the transformation should be a reflection of the y-axis. In this case, this doesn't apply because, as we saw before, negative x squared is the same as negative x squared. Therefore, the parent function x squared cannot be reflected off the y-axis. This is a general formula to find what transformations are happening as you change certain parts of an equation. If it's positive, there will be no change. If it's negative, it'll be reflected off the x-axis. If it's greater than 0, it'll be stretched. If it's less than 0, it'll be compressed. If it's equal to 0, no change will happen. If it's negative, it'll be reflected off of the y-axis. If it's positive, again, there will be no change. If it's positive, it'll be moved to the left. If it's negative, it'll be moved to the right. If k is positive, the graph will be moved up. If k is negative, the graph will be moved down. Now that we understand how the different parts of an equation can cause certain transformations, let's look at this example of an equation and find the transformation. The function given is f of x equals negative 3x cubed plus 5. So the original function is x cubed. The leading coefficient is negative 3, which tells us that the function is reflected off the x-axis. And is also stretched by a factor of 3. K is equal to positive 5, which means that the function will move up 5 units. These are all the transformations of this function. Now let's try to find the equation when we're given the transformations. The shape of absolute x but moves 10 units up. 4 units to the left, stretched by a factor of 2, and reflected across the x-axis. So we know the parent function is the absolute value of x, and the b is positive 4. K is equal to positive 10, and there's a leading coefficient of negative 2. This means that our function went from f of x equals the absolute value of x to negative 2 times the absolute value of x plus 4 plus 10. What's she write? What did she write?
Don't worry about it, fool.
I'm gonna punch you in the vagina.
Somebody say, hey! Come here.
Slide him through. I just feel the music, man. Can we turn the lights on and off and on and pretend this is a rave? Rave.
And then the light